A beetle mixes two chemicals inside its own abdomen and fires the result out of its body at close to 212 degrees Fahrenheit. It does this while it is being eaten, and then it walks away. Evolution is usually described as economical. This video is about 8 times it wasn't. 8 defenses built at a price no accountant would sign off on. Ranking them means deciding what too far actually means. 3 things settle it. What the defense costs the animal using it, a chemical it has to rebuild, a body part it gave up, or its life. How improbable the mechanism is, measured against anything an insect ought to be capable of, and whether the defense ends up doing the opposite of what a defense is for. Cost decides it. Where 2 defenses cost the same, the stranger one ranks higher. In today's video, we're ranking 8 insect defenses where evolution went too far. The defense at the top of this list has no explosion, no venom, no spray, and nothing to aim. It costs a life every time it is used, and it gets used on nights when nothing has come. The reason it wins isn't the mechanism, it's the bill. To find the first one, we're heading to Texas. The 2-striped walking stick aims for your eyes, and it does not miss. 2 at once, one riding the other, and a fine jet leaving the thorax. Paired glands fire an aimed terpene spray a foot or more, working from the day the insect hatches. If it reaches your eye, the range runs from chemical conjunctivitis to a corneal ulcer. An insect built entirely around not being seen has a backup plan that is pure aggression. Stewart's case report from 1937. A Texan, watching a pair from 2 feet away, took the discharge in his left eye. He described the pain as molten lead. By morning, the cornea was almost scarlet. He lost 2 days of work and 5 days of clear vision, then recovered completely. Larger females run dry after as few as 5 discharges and need 1 to 2 weeks to refill. Cases are on record in humans and dogs. No fatalities, no permanent blindness. The 2-striped walking stick takes the 8th spot. On the shore of Lake Victoria, an assassin bug glues its victims to its back and hides inside the pile. A walking heap of dead ants, with 6 legs underneath it. The nymph drains ants and cements the empty shells to its abdomen, building a mound that can be larger than its own body. Jumping spiders avoid ants because ants arrive in numbers, though swarm mimicry is the researcher's proposal, not settle. It is not disguised as nothing, it is disguised as the one thing its predator refuses to attack. Jackson and Pollard, 2007, showed 3 species of jumping spider, hunters that work almost entirely by sight, bugs with the mask on and stripped off, some alive, some lures made from dead ones so movement could play no part. The spiders went for the bear bugs significantly more often. The mask worked on the dead ones just as well. Only nymphs build it. Adults carry nothing. The same trick turns up in Malaysia. The corpse-carrying assassin bug takes the 7th spot. West across the continent to RBR State, Nigeria. A beetle with no bite, no sting, and a toxin that only works once you have killed it. A single burn running in a straight line down a forearm, exactly where a hand brushed. Pederin sits in the beetle's own blood, and it isn't the beetle's chemistry. A bacterium only the female carries makes it and passes it to her young. A beetle walking across your skin does nothing. Wipe it off and you spread it yourself. Hours later, a burning streak appears and blisters, and the discoloration can last months. The defense has no delivery system. The victim applies it. In late 2021, a report from a youth service camp at Umuna described 157 recruits with the same linear rash. The burns heal in 1 to 4 weeks, and outbreaks run from Nigeria to Iran to South Sudan. The rove beetle takes the 6th spot. It never spends anything. It is spent. Now to a laboratory bench in Kobe, Japan, and to the beetle this video opened on. The bombardier beetle can be swallowed alive and detonate its way back out. A toad's mouth opens and a live beetle walks out of it. Hydroquinone and hydrogen peroxide are stored apart and mixed in a chamber at the abdomen's tip. The reaction is explosive and leaves the body at around 212 degrees. How it survives an hour and 3/4 inside a stomach is not known. The researchers say so themselves. The two toads split sharply. Bufo japonicus, which shares the beetle's habitat, brought it back up 34.8% of the time. Bufo torrenticola, which doesn't, gave it up 57.1%. The predator that knows this beetle has learned to keep it down.
In 2018, Shinji Sugiura and Takuya Sato fed the beetles to Japanese toads and listened. The explosions were audible from inside the toads. 43% brought the beetle back up, 12 to 107 minutes after swallowing. Every beetle that came out was alive. Beetles drained of their chemicals beforehand were almost all digested. One of the survivors was still alive 562 days later. The Bombardier beetle takes the 5th spot, and if a beetle that detonates inside a stomach only rates 5th, because it survives, and everything above it pays more, the list gets stranger from here. To French giana, and a termite that grows a bigger bomb as it becomes less useful. 2 bright blue dots on the back of a pale, otherwise unremarkable worker. The weapon is 2-part, held apart until the body fails. Copper-bearing crystals sit in pouches where the thorax meets the abdomen. The harmless hydroquinones they react with are stored inside. Rupture mixes them, and only then does the droplet turn toxic. The crystal volume and the readiness to rupture both rise with age as its ability to gather food falls away. The colony does not retire its old workers, it arms them. Shobotnik, Harnous and colleagues published it in Science in 2012. They had noticed workers came in 2 kinds, plain white and ones marked with 2 dark blue spots. Lifted with forceps, the blue ones burst in their hands, releasing a sticky droplet along with fragments of gut and internal organs. The crystal structure was resolved only in 2024, 12 years later. The blue backpack termite takes the 4th spot. Back to Japan. Not a bench this time, but a hive entrance at Tamagawa, where bees cook a hornet alive at a temperature they survive and it doesn't. On a thermal camera, a single white hot sphere in a dark hive. The bees read the hornet's marking pheromone and mass at the entrance. When a hornet is seized, hundreds pile on and vibrate their flight muscles. Heat alone would not finish it. Carbon dioxide inside the ball reaches about 3.6%, dropping the hornet's lethal limit into the ball's range. A species that cannot sting the hornet kills it with the only surplus it has, and only because it is suffocating it too. In 1995, Ono and colleagues put a thermal camera on the ball. The core sat at roughly 117 degrees. More than 500 bees hold that for 20 to 30 minutes. The hornet dies at 113 or 115, the bees at 122 or 124. The Japanese honeybee takes the 3rd spot. Southern Australia, and a soldier that traded its mouth for a glue gun and cannot feed itself. Its head is mostly nozzle. The head is a pressurized gland with a spout on the front. The mandibles are vestigial and cannot chew. Terpene glue fires through the nozzle, hardens in air, and entangles attacking ants. Workers feed the soldier mouth to mouth for its entire life. The soldier cannot last without the workers it exists to protect, and its weapon works best when the victim tries to clean it off. In 1976, Thomas Eisner's team put these soldiers against live ants and against dummies built from a magnetic stirrer. It was glue, and it slowed an ant at once. It was also an irritant. The gummed ant grooms itself, and every stroke works the glue deeper in. It finishes the job itself. The irritant traces to 2 monoterpenes, alpha-pinene and beta-pinene. A sprayed site holds other soldiers in the area for up to a few days. The Naysut soldier termite takes the 2nd spot. Which leaves 1, in a sugarcane field near São Simão, Brazil. It is the first animal known to kill itself defending against a threat that has not arrived. An ant, 1/12 of an inch long, kicking sand into a hole that is already almost invisible. Every evening at sunset, Pharalius pusillus closes its nest. Most of that work happens from the inside, the way it does in any ant colony, but the last of it cannot. Somewhere between 1 and 8 workers finish the seal from the outside, filling and smoothing the entrance until the ground reads as ground, and when it is done, they have no way back in. They are dead by morning. The authors described it as the first known case of preemptive suicidal defense. Not a last stand, not a sacrifice under attack, but a routine expense, paid nightly, in advance, against nothing in particular. Every other defense on this list answers something. This one answers nothing. It is paid every night, in advance, against whatever might not come, and the colony can afford it. Tofilski and colleagues published this in The American Naturalist in November 2008. They had gone to Simo to study how the ants move sand and noticed that as many as 8 workers were still outside after the nest had closed. They were not stragglers. They were carrying and kicking sand into the entrance for a quarter of an hour or more until it was indistinguishable from the ground around it. That the sealers die is the study's inference, not its observation. The authors could not simply go back and count bodies, and they say so. 1 to 8 workers a night. At least 15 minutes of sand to close an entrance already almost invisible. And that is why it takes the top spot. Not because it is the most extreme mechanism on this list, but because it is the least. No explosion, no venom, no heat, no spray. An ant moving sand. The loudest thing on this list was 5th. The beetle we opened with walks away from what its defense costs. This one seals the door and stays outside every night for an attack that mostly never comes. That isn't evolution going too far. That's evolution paying exactly what it was asked. There are others. A blister beetle, ants that block their own nest doors with their heads, a ladybird. But the argument I want is about 5th place. A beetle that detonates inside a stomach and walks out alive is sitting behind an ant with a shovel. Tell me where you would have put it and what you would have moved to make room. Thank you for watching, and I'll see you next time.